Good morning. We are going to discuss about introduction to cloud computing and its fundamentals. The topics we are going to discuss are computational models before cloud computing. They are standalone computing, centralized computing, client server computing, decentralized computing, and distributed computing. Next is cloud computing. The topics we discuss in cloud computing are definition of cloud computing reference model, types of cloud computing services, cloud computing deployment models, utility computing, pros and cons of cloud computing service providers. Actually, cloud computing is a new technological advancement that supports better utilization of IT resources through internet. It adopts a pay-per-use approach. The figure shows the concept of cloud computing. The service providers maintains infrastructure, software, applications in the data centers. These IT resources are made available to users through internet. Users uses these IT services through their laptops or desktops or mobiles via internet. Availability of IT resources through internet is called cloud. Accessing IT resources available in the cloud through internet is called cloud computing. Before discussing the cloud computing, let us know about computing using a standalone computer. A desktop or laptop is treated as a standalone computer. Figure shows desktop computer, laptop computer, and the block diagram of a digital computer. This contains CPU and peripherals. We install operating system, required software, then we write programs, we compile programs, we execute programs. During execution, the program is processed in the local computer only. The program is stored in the local computer. The input and output also available in the local computer only. Everything is in local computer, so it is said to be a standalone computer. Before cloud computing emerged, there was client server computing, centralized computing, decentralized computing, and distributed computing. Let us discuss about centralized computing. In a centralized computing, all or most of the processing and data storage is done on a single central server. The diagram shows that there is a server and there are many clients connected to server. All servers they use to perform their task using the server. All the programs will be stored in the server, and whenever a particular client wanted to execute, the server executes that program and returns the result to client. If every client wanted to execute its own program, all programs are stored in the server, all the data also placed in the server executes all the programs, and the results of the respective programs or respective clients will be sent back to clients. So here server acts as a central computer, so it is said to be centralized computing. Because here we are using many clients and a single server, it is said to be client server computing. Now it is decentralized systems. In a client server environment, there is one server, many clients. The workload of all clients is performed by the central server. If you use more than one server to serve the needs of clients as shown in the diagram, that environment is said to be decentralized environment. The storage and processing of clients is shared by more than one server is treated as a decentralized system. Here also clients acts as input-output devices. Server used to store programs, data and executes the programs. The server sends back the results to clients. Distributed systems. Distributed systems are computing architectures where multiple independent nodes or computers work together to achieve a common goal. These nodes communicate and coordinate with each other over a network, appearing as a single coherent system to the end user. Distributed systems aim to improve performance, reliability, scalability, and resource sharing by leveraging the collective power of interconnected devices. Let us see the figure. There are many computers interconnected with each other. All are independent computers having storage and processor. Every system can store program and execute program, and they are able to share their resources among other computers. All the computers acts as clients as well as servers. Whenever a computer requests other computer for a particular resource, it will act as a client. Whenever a computer responds to the request of a client, it acts as a server. Suppose we have a program having 4 modules or functions. Each function can be executed on a different computer, and the output can be combined together to form the solution of original program, which is divide and conquer model of execution. The distributed computing environment supports divide and conquer approach for the faster execution of a modular program. Now, let us discuss about the client-server computing in cloud computing. Client-server computing means there will be one server and many clients. The programs of all clients will be stored in the server and will get executed. In cloud computing, servers are located in data centers. Users connect to these servers using internet. The servers serves the needs of clients. All client programs will be executed by the server. See the diagram. There are many clients and a single server. All clients are connected to the server via internet. Clients will get their programs executed by the server. After execution, the server will send the results to the client. In this model, clients acts as input-output devices. Server stores programs, data, and executes client programs. The communication media is internet. So, performing computation in servers available in cloud through internet is called cloud computing or client server computing in cloud. Cloud computing fundamentals. See the diagram. The diagram shows a cloud and users. Cloud is collection of infrastructure, software, applications. Users are connected to cloud using internet. Users will get their services done using the infrastructural facilities that are available in cloud. What is cloud computing? Cloud computing is a new technological advancement that supports better utilization of IT infrastructure, services, and applications using internet. It adopts a service delivery model based on a pay-per-use approach. In cloud computing, users do not own infrastructure, platform, or applications, but use them for the time they need them. These IT assets are owned and maintained by service providers who make them accessible through the internet. These service providers, they maintain these infrastructural facilities in data centers. The different cloud computing applications are Gmail, Yahoo Mail, Facebook, Instagram, YouTube, Salesforce, OTT platforms, online banking services, e-commerce platforms, websites, Twitter, etc. Definition of a cloud. The cloud refers to IT resources that are accessed over the internet. See the diagram. There is a cloud which is having infrastructure platform, software applications. Infrastructure refers to servers, computers, storage units, network devices. Platform means operating systems, databases, programming language, compilers. Software applications are the programs we write for solving some application or some problems. The IT resources are servers, computers, software such as operating system, compilers, software applications, databases, storage units, networking, etc. Users can access these IT resources through internet. These IT resources are being maintained in data centers made available to users. So accessing IT resources via internet is called cloud. Availability of IT resources through internet is called cloud. Cloud means availability of IT resources via internet. Cloud computing means performing computation using IT resources available in cloud through internet. Users can connect to cloud and can execute their programs in the servers available in the cloud. Cloud computing is a technological advancement that supports better utilization of IT infrastructure services using internet. It adopts a service delivery model based on pay-per-use approach. Users do not own infrastructure platform applications but use them for the time they need them. IT assets are owned and maintained by service providers who make them accessible through the internet. Data centers. Cloud means availability of infrastructure, software, applications over internet. The infrastructural facilities are made available in data centers. Cloud providers establishes data centers in which they make all these IT resources available. See the diagram. A data center contains servers, storage units, networking tools, other infrastructures, software. The major advantage of cloud computing is the user can only concentrate on the job while leaving the problems behind, as they need not own or maintain infrastructure. The following are some of the companies established data centers: Amazon Web Services, Microsoft Azure, Google Cloud, IBM Cloud, HP Cloud, Salesforce, Alibaba Cloud, Oracle Cloud. The vision of cloud computing. The vision of cloud computing is something related as follows. For someone desires to grow their infrastructure but they do not know how long they need the infrastructure. For someone who cannot invest on infrastructure but just started their business. For someone who is having lot of infrastructure and wanted to rent. For someone having surplus infrastructure and want to make use of that. For someone who is having infrastructure and middleware and can host applications. For someone having infrastructure and can provide application services. For someone who can focus on application logic and enables to focus on maintaining and scaling of infrastructure. For someone who wanted to access documents from anywhere. These makes the vision of cloud computing. Cloud computing or utility computing. Performing computation on IT resources using internet is treated as cloud computing. Cloud computing allows renting infrastructure, runtime environment, software services on a pay-per-use basis. Utility computing is a subset of cloud computing. We treat computing as utility. In general, we pay for utilities such as electricity, water, telephone, food. We pay for the electricity based on units we have consumed. We pay for the water based on water meter reading. We pay for telephone bill based on the number of calls we made. We pay for food based on the order we made to eat. In the same fashion, computing also can be considered as utility. We pay for the infrastructure or IT resources for the time we used is called utility computing. Next is philosophy of cloud computing. I don't care where my services are, who manages them, where my documents are stored, or where my applications are hosted. I just want them always available and access them from any device connected through internet. And I am willing to pay for this service as long as I need it. History of cloud computing. Before cloud computing emerged, there was client server computing. All the clients store their programs data in the central server. The server takes care of computation of programs of all the clients. Clients acts as input output devices. Distributed computing concept came after this, where all the computers are networked together and resources are shared when needed. The cloud computing concept came into the picture in the year 1950 with the implementation of mainframe computers, which is made accessible via thin or static clients. Then, in 1961, John McCarthy delivered a speech at MIT in which he suggested that the computing can be sold like a utility like electricity and food. The idea was great, but it was much ahead of its time, and despite having an interest in the model, the technology at the time was not ready for it. In 1999, Salesforce.com became the first company to enter the cloud arena, excelling the concept of providing enterprise level applications to the end users through the internet. Then, in 2002, Amazon came up with Amazon Web Services, providing services like computation, storage, and even human intelligence. In 2009, Google Apps and Microsoft Windows Azure also started to provide cloud computing enterprise applications. Other companies like HP and Oracle also joined the stream of cloud computing for fulfilling the need of greater data storage. Cloud computing reference model. A cloud computing reference model is a structured framework that organizes cloud services, components, and functions to help understand and standardize cloud architectures. It is often broken down into layers with common models featuring the three main service models: infrastructure as a service, platform as a service, software as a service. The figure 14a shows the reference model. Cloud provides cloud services, infrastructure as a service, platform as a service, software as a service. Users uses these services via internet. There may be many users using cloud services. Figure 14b shows there are number of users using cloud services. There are many layers or interfaces to perform cloud computing. The layers are physical layer, virtual layer, control layer, service orchestration, and service layers. Types of cloud computing services. The cloud provides the following services: infrastructure as a service IaaS, platform as a service PaaS, software as a service SaaS. Infrastructure as a service. IaaS stands for infrastructure as a service. With the help of IaaS, the user can use IT hardware just by paying the basic price of it. Infrastructure means servers, storage devices, network switches, routers, physical machines, virtual machines. Some of the IaaS service providers are EC2 of AWS. EC2 means Elastic Compute Cloud of Amazon Web Services, Virtual Machine of Microsoft Azure, Google Compute Engine of GCP, Google Cloud Platform, Salesforce, Oracle, IBM, SAP. PaaS, Platform as a Service. PaaS stands for Platform as a Service. This helps the user by providing the facility to make, publish, customize the software in hosted environment. An internet connection helps to do it. It also has several benefits such as it has a lower cost and only the user has to pay for the essential things. Platform means operating systems, environment of facilitating execution of programming language, that is compilers or interpreters, middleware, databases, database servers, web servers. Providers of PaaS are Google App Engine, AWS, Elastic Bean Stack, Microsoft Azure App Services. SaaS, Software as a Service. SaaS stands for Software as a Service. It provides a facility to the user to use software from anywhere with the help of an internet connection. It is also known as software on demand. The remote access is possible because of service providers host applications and their associated data at their location. There are various benefits of SaaS as it is economical and only the user has to pay for some of the basic costs such as licensing fees, installation costs, maintenance fees, and support fees. Examples of SaaS are Yahoo Mail, Hotmail, Gmail. Software is of two types: system software, application software. In here, we consider application software. Application software is on demand software. Cloud deployment models. There are 4 cloud computing deployment models that vary as per the requirement. The cloud deployment models are: first one, private cloud; second one, public cloud; third one, hybrid cloud; fourth one, community cloud. A figure shows all the 4 cloud deployment models. Private cloud. Private cloud is a dedicated single tenant environment. The cloud company offers cloud services to one organization only. A dedicated single tenant environment. It offers cloud services to one organization only. The organizations which do not want to share resources as they have very sensitive data, such organizations use private cloud. For example, banking services, financial services, insurance services, organizations having sensitive data do not want to share their resources uses private cloud. Then public cloud. Public cloud offers IT resources, that is servers, storage, apps over internet managed by third party like AWS, Azure, Google Cloud, allowing users to access scalable on-demand services via web browsers on a pay-as-you-go basis, eliminating the need of hardware ownership and maintenance. In public cloud, the company serves the infrastructure to the consumer on a commercial basis. Public cloud shares resources among common users. Public cloud is a multi-tenancy environment. Many users share the same server, storage devices, network resources, etc. The mother server may be broken down into many virtual servers and assigned to different users so that many users share the same resources. Majority users uses public cloud environment. Hybrid cloud. Hybrid cloud combines public and private cloud services, giving businesses the best of both. This setup allows companies to store sensitive data privately while using cost effective public cloud resources for non sensitive workloads. For example, in software development, teams often use a public cloud to host projects and a private cloud for secure testing. This approach offers flexibility, cost saving, and better control over data and applications. Community cloud. The companies having similar interests and work can share the same cloud, and it can be done with the help of community cloud. The initial investment is saved as the setup is established. Community cloud shares infrastructure to multiple organizations which is having common goals. Utility computing. Utility computing is a service provisioning model that offers computing resources such as hardware, software, and network bandwidth to the clients as and when they require them on an on demand basis. The service provider charges only as per the consumption of the services rather than a fixed charge or a flat rate. Just like we pay for electricity, water, telephone services, we pay for IT services in cloud computing. This kind of computing is said to be utility computing. We pay for electricity for the units we consumed. We pay for water based on meter reading. We pay for telephone based on the calls we made. We pay for food based on the order we made for food. In the same way, we pay for computational resources for the time we used them. The concept of utility computing is simple. It provides processing power when you need it, wherever you need it, and at a cost of how much you use it. Differences between cloud computing and utility computing. The table shows the differences between utility computing and cloud computing for the features mentioned. Utility computing is a subset of cloud computing. Let us consider the first feature, characteristics. Utility computing provides computing resources as a utility service, whereas cloud computing offers a range of services over the internet. Second feature, scalability. In the utility computing, users are allowed to scale the resources up or down based on the demand. In cloud computing, cloud provider provides scalable resources to meet varying needs. Third feature, pricing models. In utility computing, users pay for resources consumed on a usage based model. In a cloud computing, it offers various pricing models including pay per use or subscription based pricing. Next feature, resource allocation. In utility computing, users have control over resource allocation and can adjust as needed. In a cloud computing, resource allocation is managed by a cloud provider offering predefined configurations. Next feature, performance. In utility computing, performance can vary based on resource allocation and infrastructure. In cloud computing, performance can be optimized with scalable resources and distributed infrastructure. Next feature, reliability. In utility computing, reliability depends on the service provider's infrastructure and support because it is cost effective. In cloud computing, reliability is ensured through redundant infrastructure and service level agreements. Examples of utility computing. We have discussed three different services: travel reservation service, online retailers, startups, and small businesses. Let us consider first one, travel reservation services. The travel and hotel industry is a highly dependent on seasonal demand and in peak festival times. During holidays, people used to visit different places. We can see a surge in demand for tickets to exotic destinations. Due to the rise in demand, travel reservation applications will deploy additional infrastructural support and virtual servers to manage the offset of travelers wanting to make their reservations. This way, travel applications gets extra resources on board when they require and pay only based on their consumption. Next is online retailers. During festive season, online retailers will witness massive traffic jumps and endure extreme load on their servers. The percentage of people using the e-commerce sites will rise many times than usual days during festive season. The regular infrastructure may not sufficient to deal with the overwhelming searching of the buyers. Due to the rise in demand, e-commerce applications will deploy additional infrastructural support and virtual servers to make the demand of the consumers wanting to make their purchases. This way, e-commerce applications get extra resources on board when they require and pay only based on their consumption. Next is startup and small businesses. Let us say a startup sets up a new business and uses utility computing services to rent hardware units such as CPUs and storage. Once their business catches the eye of thousands of customers, they would need to scale up by requesting more resources, bandwidth, and data storage space. Through this method, the startup only needs to pay for the resources it utilizes and can focus on flourishing its business without the worry of ongoing operational costs hindering business growth. Characteristics of cloud computing. Cloud computing is defined by several core characteristics that distinguishes it from traditional on-premises IT infrastructure. These traits enable the flexibility, scalability, and cost efficiency central to modern digital services. The National Institute of Standards and Technology identifies five essential characteristics of cloud computing. First one, on-demand self-service. Second, broad network access. Third, resource pooling. Fourth, rapid elasticity. Fifth, measured service. First one, on-demand self-service. Users can automatically configure the computing resources without human interaction from the service provider. The second one is broad network access. IT resources are available over the network which can be accessed through internet. Third one, resource pooling. Resources are pooled in the data centers to serve multiple consumers using multi-tenant model. Fourth one, rapid elasticity. Users can scale up and down the resources. Users can scale up the resources whenever user needs additional resources and can scale down the resources whenever you don't use the resource. Scaling the resources up or down based on demand. Fifth one, measured service. Systems automatically control and optimize resource utilization through metering, providing transparency for both provider and consumer. Advantages of cloud computing. There are several advantages of using cloud computing: economical, 24 by 7 availability, security, scalability and flexibility, speed and agility, global deployment in minutes, disaster recovery and backup, automatic software updating. Let us discuss each and every one in detail. First one, economical. Cloud computing is economical as the user has many free opportunities when they start using it, and after that they have to pay only for basic services. There are many reliable services available for no cost or low cost for the use of the general public. The second advantage is 24 by 7 high availability or high availability. The cloud service is available every time as all the queries and issues are resolved with the help of technical support available in data centers. The users can get assistance from anywhere. Third advantage is security. As the data has been saved at multiple places, there is no loss of data. Cloud computing offers a high level of security as the data stored is important and should not be lost. The data can be modified or deleted from anywhere with remote access. Fourth advantage, scalability and flexibility. You can easily scale up or down the resources as required. Cloud computing also provides flexibility in how you manage IT infrastructure and applications. Even if the device is lost, the data can be modified or deleted from anywhere with the help of an internet connection. Fifth advantage, speed and agility. It is very fast and active processing. Then global deployment in minutes. Applications and services will be deployed globally within minutes. Disaster recovery and backup. Built-in backup and recovery systems ensure data availability and rapid restoration after incidents of disaster. Next advantage is automatic software updating. Providers handle software and security updates, ensuring users always have the latest features without manual IT effort. Next is disadvantages of cloud computing. Downtime, vulnerable to attack, internet dependent. Downtime. One of the major disadvantages of cloud computing is downtime. Cloud computing downtime is a period when a cloud service becomes unavailable or is not functioning correctly, resulting in an interruption of service for the users. It can be caused by planning events like maintenance or unplanned events such as hardware failure, software bugs, cyber attacks, or human errors. Vulnerable to attack. If you are connected to the internet, there are chances that you suffer severe attacks as you are exposed to potential vulnerabilities. The chances are less, but sometimes even the best team suffers. Internet dependent. Without internet, you cannot access cloud. Next is cloud service providers. Cloud service providers offers various services such as software as a service, platform as a service, infrastructure as a service, network services, business applications, mobile applications in the cloud. There are many cloud service providers like Amazon Web Services, Microsoft Azure, Google App Engine, IBM Cloud, Salesforce, Alibaba Cloud, Oracle. For example, AWS, Amazon Web Services. Amazon Web Services was started in 2006 to help companies avoid high cost and effort of buying and managing their servers. Before AWS, businesses had to set up physical computers and storage to run websites or apps, which took time and money. AWS came into market to solve this problem by offering these resources over the internet. AWS and its core capabilities. Amazon Web Services is a cloud platform offered by Amazon that lets people and companies use IT services like storage, servers, and databases through the internet. Instead of buying and maintaining physical computers, you can rent these services online and only pay for what you use. Amazon Web Services offers over 200 services including EC2, Elastic Compute Cloud, a core AWS service, provides virtual servers for running applications. S3, Object Storage for Files and Media. RDS, Managed Relational Databases. Lambda, run code without managing servers. From startups to large enterprises like Netflix, Airbnb, and NASA, AWS is widely adopted for its flexibility, scalability, and security. Next cloud provider is Microsoft Azure. Microsoft Azure is one of the widely used cloud computing platforms. Azure was designed by Microsoft in 2010. Azure provides a wide variety of services such as cloud storage, compute services, network services, cognitive services, databases, analytics, and IoT. It makes building, deploying, and managing applications very easily. AWS supports various operating systems, databases, programming languages, frameworks that allows IT professionals to easily build, deploy, and manage applications through a worldwide network. Google App Engine. Google App Engine, also referred as GAE or App Engine, is a cloud computing platform used as service for developing and hosting web applications. Google App Engine is a scalable runtime environment. It offers a secure execution environment in addition to a number of services. App Engine makes it easier to develop scalable and high performance web apps. Google's applications will scale up and down in response to shifting demand. Cron tasks, communications, scalable data storage, work queues, and in memory caching are some of these services. The development and hosting platform, Google App Engine, which powers anything from web programming for huge enterprises to mobile apps, uses same infrastructure as Google's large scale internet services. It is a fully managed PaaS platform as a service, cloud computing platform that uses inbuilt services to run your apps. You can start creating almost immediately after receiving the software development kit. You may immediately access the Google App Developers Manual once you choose the language you wish to use to build your app.